All right, this video is 3.3 properties of logarithmic functions. We're going to be delving a little bit deeper into log functions and some of the rules and properties that they have. So let's just get started. If I can get the slide to advance. All right, so the first property is called the product property of logarithmic functions. Um, we have here log, our base is b of c times d. If I have a log with a multiplication in here in the parentheses, I can expand that log out so that it is log base b. Notice b is the same in all three of them. Log base b of c plus log base b of d. So if I have a product here, remember product means the answer to a multiplication problem. If I have a product in here, I can rewrite this log using two logs. It's called expanding the log out. I can write it as log base b of c plus log base b of d. So an example here is that I have log base 2 of 4x. This can be rewritten as log base 2 of 4 plus log base 2 of x. So if I have something multiplied inside my log, so multiplied, I can add it together as two logs. Okay. The quotient property for logarithmic functions says that if I have a log base with some base of c divided by d, so I have division here, I can expand it into two different logs. Notice the base is the same all the way across. I would subtract, if I have a division in the log, I can write it as two separate logs subtracted. So log base b of c minus log base b of d. So my example here, log base 5 of 4x over 2 is log base 5 of 4x minus log base 5 of 2. Okay, I could technically expand it a little bit more with that 4x because the 4 times x I could write as log base 5 of 4 plus log base 5 of x, and then I have the minus log base 5 of 2. So I'm just using the property from the previous slide on that first part to give me this. I might need to group those together to show that those ones are multiplied before we subtract. Okay, next slide. So just a couple examples to try. So this one is multiplied. 6 and 9 are multiplied inside. So I know I could write this as two separate logs using the same base as that one with addition between the two logs. Okay, so if I see multiplication on the inside, I can write it as two separate logs added together. Okay, this one is division. So my log has base x of the top number 3, and then I will subtract log base x of 4. So if I have multiplication inside, that means I can add the logs together. If I have division inside, that means I can subtract them. I can expand them out to more than one log. Okay. So the next property is called the change of base formula. So basically what the change of base formula is it's just telling me that if I have any log, this c right here should not be a c, it should be an equals. Log, no, it should just not be there. I don't know what that is. So log base b, oh yes it should. Okay, I see what's going on. This slide is just a little bit messed up. So that's a little confusing. So what it's trying to say is if I have log base b of c, that should equal log c over log b, which also equals the natural log of c over the natural log of b. Okay, so if I have, basically this is because in your calculator, if you push the log button, it is assuming that you are talking about base 10, right? If you see a log that doesn't have a little base number, we know that base number is 10. That's the one your calculator will compute, is log base 10. So if that base number, so it could be log base 10 of x or something. If you push log in your calculator, that is giving you automatically a base 10. If you push natural log of some number in your calculator, it's automatically giving you a base of e. Okay, so if your base number here, b, is different than 10 or e, You can still enter it in your calculator. So for example, if you have log base 3 of 5, so my base here 3, it's not 10 and it's not e, but I can still use my calculator to calculate this. I just have to use this change of base formula. So basically log base 3 of 5 is the same as log base 10 of 5 divided by log base 10 of 3, which is also equal to natural log of 5 divided by natural log of 3. So no matter what the base is here, if as long as it's the same on the top and the bottom, it's going to give me the same thing as if I were just calculating log base 3 of 5. Okay, so grab a calculator if you have one. Okay, we're going to enter this into our calculator just like you see it, either one of these, either log base 5(3) divided by log 3. I'm sorry, either log 5 divided by log 3 or natural log 5 divided by natural log 3. In fact, try them both if you have a calculator. You'll get the same thing either way. So log 5, close your parenthesis if your calculator gives you one, divided by log 3 is equal to 1.465. I rounded it up there. So basically what this helps you do is use your calculator to calculate any log. So for another example, if I have log base 5 of 17, I can use my calculator as long as I use base 10 of log 17 over log 5, or you could put it in your calculator as natural log 17 over natural log 5. If I do that in my calculator here, and go ahead and try it in yours if you have one, you can even use your phone calculator. You just got to make sure you use parentheses correctly. So this would be 1.76. Okay. So the change of base formula just allows you to use your calculator to calculate any log, as long as you remember the rule here. It needs to be log of the same base over log of the same base. So because our calculator does 10, it's just going to be log 17 over log 5. Or alternatively, you could do natural log 17 over natural log 5. You'll get the same answer either way. Okay. So the last property that we're going to talk about today is called the power property for logs. So basically what that power property for logs tells me is if I have log base b of c and it's raised to the power of p, that power p can be written in front of the log. So these are equivalent. I can take this exponent and just move it out front. Those are going to be equal to each other. So for example, if I have log base 8 of 3 squared, I can take that 2 and move it down in front so that I get 2 times log base 8 of 3. These are equal to each other. Okay. So let's see if there's an example here. So if I have log base 4 of 5 to the 6th power, okay, I can take that 6, this would be expanding it. I would do 6 times the log base 4 of 5. This would be the expanded form. This is called the condensed form. Okay. Log base 6 of 10 has no exponent on there, so that's not very interesting, so you would just leave it like this. What we could do here is we could calculate this in our calculator using the change of base formula. This would be log 10 divided by log 6. So this bigger number that's kind of a little bit above 6 goes on the top because it's above, and this one, the log 6 goes on the bottom, just an easy way to remember which one is which. So if I put that in my calculator as either log 10 over log 6 or natural log 10 over natural log 6, I get 1.285. Okay, I think that's it for the slideshow here, but I would like to go over a few more examples here. So let's head into a similar worksheet to this is similar examples to the one that will be on your worksheet, like that has all the same headings and things. So the first two sections here, you're just rewriting if it's in exponential form, you're going to write it in log form, and if it's in log form, you're going to write it in exponential form. So this is kind of a review from what we did last unit, right? I can write this as log base 16 of 1 equals 16. I did that backwards. All right. Log base 16 of 16 equals 1. Remember, it should always equal the exponent. So 16 to the first power equals 16 is the exponential form. So this would be log base 13 of 1 equals 0. So we want to write this one in exponential form, so that'd be p to the m power equals q. So we're just changing forms, just like we did last unit, or 5 squared equals 25. This next section, you're going to use your calculator. So this is using the change of base formula. So I'll put that in my calculator as log 9 over log 4. Remember, you can also use natural log. That works too. This one I would put in just as it is because the base does not exist there. So that means it's just log base 10. So on that one, you can just literally put it in your calculator like that because the base already matches the one in your calculator. But these other where the base is different, you need to write it as 2 logs. Log 6.7 divided by log 5. This one would be log 33 divided by log 6. And then actually put that in your calculator, calculate it, and tell me what those equal. On this next section, we are expanding the log. So we're going to use a couple of different properties together here because we have powers up on here as well. So the first step is because I'm dividing this log, the log would be base 10 because I don't see a log, so I don't need to write that. Because I'm dividing, I'm going to subtract between the two logs. So I'll have log of 12 to the 5th minus log of 5 to the 3rd. And then I'm going to take these exponents and then I'm going to move them out front of each of these logs. And that's in fully expanded form now. Okay, so in this one I'm multiplying inside, so I need to change this to the addition of 2 logs. But before I do that, let's deal with this exponent. Since it's outside of the parentheses, it means it's going to be on u and on v. U and v are multiplied together, so this would be log base 9 u squared times v squared. So I can rewrite this as log base 9 u squared plus log base 9 v squared. Remember, anytime I'm multiplying on the inside of the log, I can expand that into 2 separate logs with a plus between them. And then those exponents can go out front. So 2 log 9u plus 2 log 9v. So that would be the fully expanded form. Okay. So on this one, we have 3 things that are being multiplied together. So we can write this as 3 separate logs. Log base 6 of x plus, remember if I'm multiplying inside, I'm going to add these logs together. Log base 6y plus log base 6z. And that would be fully expanded. There's no exponents here. Okay, number 12, we would be subtracting the 2 logs because inside we're dividing. So log base 6a to the 6 minus log base 6b. And then that 6 goes out in front of the log that was the exponent. So there's our fully expanded form. Okay. So I'm not going to do every one of these, but we'll do one more. Let's do number 15. So on 15, I have 10 to the 4th times 3, and then I also have 4 on the outside. I need to raise everything on the inside to that extra 4th power. And remember, if I already have an exponent on something and then I raise it to another exponent, I would multiply the exponents together. So this would be log base 5 of 10 to the 16 times 3 to the 4th. And then because I'm multiplying on the inside of the log, I can write that as 2 separate logs with addition between. And then finally, those exponents go out in front of the log. So I have, oops, that looks terrible, but 16 log base 5 of 10 plus 4 log base 5 of 3. That would be the fully expanded form. I can't handle it. I can't read it. Okay. On number 16, similar. We don't have an exponent on the outside, so we can just go ahead and write this. This would be log base 4 of 5 plus log base 4 of 12 to the 4th. But remember that 4 can come in front of the log. And same thing here. This one would have a 4 in front of it because my exponent is 4. So this would be the fully expanded form. Okay, and then the last section, you're going to be asked to condense them into a single log. So basically, you're going the opposite direction as the previous examples. You're starting with the expanded one, and you're going to write it back as a condensed log. So the first thing we want to do is take these numbers that are in front of a log. This one's a natural log, but all the same rules still apply. So this 6 is going to become the exponent again on both of these. And then we're going to write this as natural log. There's a plus between, so I know that 8 and 8 to the 6th and 5 to the 6th are getting multiplied together inside. So I can write it as natural log 8 to the 6th times 5 to the 6th. You could also write it just as natural log of 8 times 5 raised to the 6th, the whole thing. Either one of those are equivalent. Okay. Again, we have a plus here, so these numbers in front are going to become our exponents again, and then we're going to condense them into 1 log base 7. Since it's a plus between, we're going to multiply the 11 squared and the 12 cubed. Okay. Let's do number 20. We have a minus between here. Because there's a minus, I know I'm going to be dividing inside my log base 7. The x is going to have an exponent of 6. The y is going to have an exponent of 6. And again, because of the minus, I'm dividing here, so I'll have x to the 6th divided by y to the 6th. Okay, so again, I could write it like that, or I could write it as log base 7 of x over y, the whole thing to the 6th. So the exponent can be if it's on both of them, it can be on the outside or the inside. Either one works. All right, guys, good luck with today's assignment. Have a great weekend, and I will see you on Monday.